Hello student, welcome to all of you in the physics next lecture. This is the video number 15 and now we're seeing the chapter number 2, the mechanical properties of fluids. In previous lecture we have to see the Pascal's law and the experimental proof of the Pascal's law. Then we have to see here the application of the Pascal's law. First application is hydraulic lift. Hydraulic lift is used to lift the heavy object using the small force. This working of this machine is also based on this Pascal's law. Second application is that the hydraulic brake. These hydraulic brakes are also used to slow down or stop the vehicles in motion, and it is also based on this Pascal's law. Now we have to see the next point, that is nothing but the measurement of the pressure. There are the many instruments which can be used to measure the pressure. An instrument which is used to measure the pressure are called as a pressure meter or pressure gauge or vacuum gauge. There are the two instruments which are used here to measurement of the pressure. One is the mercury barometer and next one is the open tube manometer. These two instruments which can be used to measurement of pressure. First we have to see here the mercury barometer. What is this mercury barometer? It is an instrument that can be measure the atmospheric pressure, which is called as a barometer. This is the first found by the Italian scientist. Name of that scientist is the Torricelli, which find this apparatus mercury barometer. It is consist of in the form of the glass tube, completely filled up with the mercury. We have to not see here the mercury, but this portion which is fully filled up by the mercury. Hg, we have to denote here the Hg. As shown in figure, the schematic diagram is as shown in figure. A glass tube, this glass tube is near about the 1 meter length. Its diameter is just 1 centimeter, and which is the fill up about its brim by the mercury. And the level of the mercury of the glass tube is lower as same mercury split in the dish. This tube which can be the split in this dish, and a gap is created between the surface of mercury in the glass tube and close end of this glass tube. The gap does not contain any air. It is called as a Torricelli's vacuum. This vacuum portion, this is nothing but the Torricelli's vacuum. It does contain some mercury vapors in that portion. There are some mercury vapors. Now the pressure at the upper end of the mercury column inside the tube is 0. Therefore we can write here the Pa is equal to 0. Let us consider the point C. This point C, which is the mercury surface in the dish, and another point B, which is inside the tube at the same horizontal level at the point C. This point B, which is inside the tube but which is the same at the horizontal level at point C, so that the pressure C is equal to atmospheric pressure. This is the P0, and therefore the point B and C are at the same horizontal level. Point B and C, this point B and C are at the same horizontal level, and so that the pressure at the B is equal to the atmospheric pressure, this P0, and therefore PB is equal to P0. We can write here. Now the point B is at the depth h. This point B is at the depth h from the point A, and so that this rho is the density of the mercury. We can write the PB is equal to PA plus H rho G, where H is the barometric height, rho is the density, and g is the acceleration due to the gravity. But the PA is equal to 0, and therefore PB is equal to 0. So that substituting this PA is equal to 0, we can simply get the PB is equal to h rho g, where h is the height of the barometric column in the mercury barometer. In this way, we can use this instrument, mercury barometer, for measurement of pressure. Now we have to see the next instrument which can be also used for the measurement of the pressure, and that is the open tube manometer. You can see that in chemistry lab also, this manometer, and we can study here to use this open tube manometer for measurement of pressure. The diagram, schematic diagram for this open tube manometer is as shown in figure. This manometer is consist of U-shaped, partially filled with the low density of liquid such as water. Instead of water, you can also fill up it by the kerosene, and this helps to having a large level difference between this level liquid in these two arms. Then the one arms of the manometer is open. This manometer, one end is open, and the other is connected to this container D, other end of this manometer, which is connected to this container T, and which is the pressure P is to be the measured, and how many pressure in that container which can be the measure. Now the pressure at point A is the atmospheric pressure. At this point A, this pressure is atmospheric pressure, and this is nothing but the P0, and because of this arm is open to the atmosphere, and to find the pressure at point C, we have to find out this pressure at point C, which is exposed to the pressure of the gas in the container D. And then we consider the point B, which is in the open arm, and this manometer at the same level at the point C. This point B and the point C, which are at the same horizontal level, and the pressure at point B and C are the same. Therefore, we can write here PC is equal to PB. Now, the pressure at point B is pressure at point B, which is given by the P0 plus H rho G, where H is the barometric height, rho is the density of this liquid in the manometer, and G is the acceleration due to the gravity. Then according to the Pascal's principles, the pressure at C is the same as the pressure at point D according to the principle of Pascal's. Therefore, inside the chamber, the pressure P in the container is equal to PC. Whatever pressure inside the container which is equivalent to the PC, therefore we can write here P is equal to PC, and instead of PC we can write here, because PC is equal to this PB, and we can write the value of PB, P0 plus H rho G. And if you have to, this manometer measures the gauge pressure of the gas inside the container D, then this P0 take this side, P minus P0 is equal to H rho G. In this way, this open tube manometer, which can be also used to measurement of pressure. These are the two instruments which can be used for measurement of pressure. In your exam, you can draw the diagram for this mercury barometer or open tube manometer, and you can just explain how the pressure can be measured. This is very important in this mechanical properties of fluids. Now we can see the next point in the next lecture. If these two instruments you can understand well. Okay, thank you.